Hello and welcome to the first day of 11.2. We're going to learn how to simplify radicals today. It's a very, very important skill that is used in a ton of skills throughout geometry and algebra. So you guys are going to see a lot of this next year. Here are the answers for day 2. Actually, it's all the answers for 11.1. It's day 1 and day 2. You're going to notice the numbers that they plug in are not the numbers that I have you guys plug in. And the reason for that is a lot of these are decimal values, and we don't like to graph decimals. So we picked some smarter numbers than the textbook does, actually. So if your tables look different, it's because your tables should look different. All right, here's the last page. And then let's get into 11.2, simplifying radical expressions. Okay, so there's a lot of jargon here, a lot of lingo. Okay, so the simplest form, no perfect square factors other than 1 are in the radicand, no fractions are in the radicand, no radicals appear in the denominator of the fraction. So that's a lot. I'm going to show you guys what to do, how to simplify these guys. Basically what we're going to be doing is we're going to be breaking up these numbers that are underneath this, the radicand, or the square root symbol, and that's going to allow us to simplify. So for example, if you have a number such as 32, we're looking for our perfect squares starting with 4. You want to see if you can divide one of these numbers out. So in this case, 32 breaks down into 16 and 2. And the reason why I chose 16 and 2 is because 16 is a perfect square. A square root of 16 is 4. So this simplifies to 4 root 2. The square root of 9 is actually already a perfect square, but then what we want to do is we want to break up the exponents, or sorry, the variables with exponents. And the reason why I'm doing this is because x squared, if I square root x squared, this gives me x. If I square root 9, this gives me 3. So this would be 3x, and then the square root of x, we don't know what that is. So that's just going to leave that as x. So here are a couple more examples. 24, I'd break down 24, 4 divides out, 4 is perfect square, so I'd break up 24 into 4 times 6. So that'd be 2 root 6. And then the square root of 25, x squared, actually breaks up really nicely, 5, and then x. So there's a couple examples for you guys. If you are having two numbers that are being multiplied together with both squares, what you want to do is first you want to multiply the two numbers together. So this would be the square root of 36, and then this one just happens to be 6. Here you have 4 on the outside, and then the square root of 3x times x, or 3x squared, and then you can break this up into root 3 root x squared. So square root of x squared is x, so we have 4x, and then we don't know what the square root of 3 is, so we're going to leave that on the outside, or sorry, on the inside. Here I'm going to multiply everything together. That's underneath the square root, so I have 7x, and then another x, and then y squared, so that'd be 7x squared y squared. If I simplify everything underneath the square root, so basically if you guys haven't kind of caught on here, I'm multiplying things that are underneath the radical together, or the radicals. Okay, so then we have 3 root 7 root x squared root y squared, and that'd be 3x y, and then the square root of 7, we don't know what that is. So we're going to leave that as that. Okay, if we have fractions, what you're going to do is you're going to square root the numerator, and you're going to square root the denominator. Okay, so here's a couple examples. So I'm going to square root 13. I'm going to square root 100. I don't know what the square root of 13 is, so we're going to leave that as 13. Square root of 100 is 10. Tomorrow, if there's we're going to learn how to solve the problem if there's a square root on the bottom, the denominator. If the square root's in the numerator like the 13 is here, that's okay. But if it's in the denominator and it doesn't simplify, that's not okay. And so I'm going to show you guys how to approach that problem tomorrow. So we have root 7 and then x. Couple more sample problems here. We have root 2, we have root x squared, we have root x. So the only thing that simplifies here is the x squared, and then I have root 2x left over. On this one here, I have the square root of 1, the square root of y squared, so this gives me 1 over y. Before I get to this, I want to just do one more question. I want to show you if it's a higher power. We only saw 3. So if it's a higher power, we're just going to break it up into pairs. So this would be x, this would be x, this would be x. That one doesn't simplify, so this would be x cubed root x. All right, so you're going to see things like that. And that is day 1. So this is an important section. Make sure that you understand all these questions. And if there's one that doesn't make sense, just check in with me so I can explain it to you, because we're going to be using these skills a lot now and in the future. Thank you guys.